Hey everyone, are you tired of science lessons that just kind of fall flat? You know, you're ready to move beyond just memorizing terms and into some real, genuine discovery? Well, you are in exactly the right place. Today, we're going to build a 3D science lesson right from the ground up, and we'll show you exactly how to make it stick.
So, let's get right into it. The big question is, how do we actually build one of these lessons? We've all heard the term three-dimensional science floating around, right? But what does it really mean for your lesson plan tomorrow when you're trying to teach something like plate tectonics? Let's break it down.
Okay, so to really get to the heart of what we mean by 3D science, we've got to go straight to the source. And that's the framework for K-12 science education. Seriously, think of this as our blueprint, our guide for putting together these incredible learning experiences.
And this right here, this is the core of it. 3D learning isn't about teaching facts over here, skills over there, and big ideas somewhere else entirely. No way. The real magic happens when you weave them all together. That's when students can use all three dimensions to make sense of the world.
So let's break down these three dimensions. I like to think of it like building a house. The disciplinary core ideas, the DCIs. That's your stuff. The bricks, the wood, the foundational knowledge. The science and engineering practices, or SEPs, those are your tools. What you do with the materials. And finally, the cross-cutting concepts, the CCCs. While those are the blueprints, the architectural plans that connect everything and give it all meaning.
Every single great 3D lesson starts in the same place. And it's not with a vocabulary list or a textbook chapter. It starts with a puzzle, a real-world event, something observable that sparks that curiosity and makes your students lean forward and ask, wait, why does that happen?
And for our plate tectonics lesson, we've got the perfect puzzle, the Pacific Ring of Fire. I mean, this isn't just a line on a map, right? It's a place of constant geological drama where the Earth is literally remaking itself. It is the ultimate why question to get a lesson started. All right, so now we have our phenomenon. Let's see how we can use the Ring of Fire as the engine for our whole 3D lesson. We're going to take this one powerful, real-world example and connect it to each of our three dimensions. This is how we turn a standard topic into a real journey of discovery.
So first up, our disciplinary core idea. Look, the Ring of Fire isn't just some random collection of volcanoes and earthquakes. It's a direct result of plate tectonics. But instead of just telling our students that fact, we let them use the phenomenon, the Ring of Fire itself, to actually discover the power of this huge unifying theory on their own.
Next, we get to the practices. This is where the students get to get their hands dirty, you know? Picture them building models out of clay, smashing them together to show how mountains form, or using real-time earthquake data from the web to map out the edges of the tectonic plates. They stop just learning about science and they start being scientists. It's a game changer.
And this is where it all clicks into place, the cross-cutting concepts. This is where students zoom out. They start to see the big picture. They recognize the obvious pattern in the Ring of Fire. They connect the cause, that's the plate movement, to the effect, the volcanoes and earthquakes. And they grasp this massive idea of stability and change, that our planet isn't static, it's always in motion.
Okay, so we've got all the pieces. How do we actually structure a lesson to bring this all to life? A 3D lesson isn't a straight line. It's more like a winding path of discovery, and the best part is, the students are in the driver's seat. Just look at the difference here. The traditional lesson flow? It's basically a monologue from the teacher. But the 3D flow? That's a conversation. It's a fundamental shift from students just learning about stuff to them actively figuring it out. And honestly, that shift makes all the difference in the world.
So, it only makes sense that a new way of teaching is going to demand a new way of assessing, right? A simple vocabulary quiz just isn't going to cut it anymore. Our assessments have to be just as three-dimensional as our lessons are.
Yeah, 3D assessments are all about application. Can your students take what they've learned about the Ring of Fire and use it to explain a totally new phenomenon, like how the Himalayas were formed? Can they write up a real scientific argument and defend it with evidence? When they can do that, that's when you know they've truly gotten it.
And at the end of the day, this is why we do it. This quote says it all. We're not just teaching science facts, we're building a generation of critical thinkers, people who can be informed citizens and who will keep learning for the rest of their lives. That is the true power of 3D science, and it all starts right there in your classroom.
So now you have the blueprint. You've got the tools to start building your own amazing 3D science lessons. So the only question left is, what real-world puzzle are you and your students going to dive into next? The possibilities are literally as vast and exciting as the world right outside your window.